Hi, welcome to GCSE Physics AQA paper number 1, and this was released in 2021. Alright, so this is for the higher tier, so it's going to be a little bit difficult, but it's not triple. So let's get started. The first one, here you have a car, nice electric car, next to a charging station, all connected. They're asking you, what does direct potential difference means? So it's not really linked to this topic, but just if you remember what DC means, that will inform you what this means as well. So direct current means, or direct potential difference mean something that flows in one direction. So potential difference across one direction or in one direction. Okay, that will be the first answer. The second one, here you have energy, power, time. You need to memorize this equation. Energy is power times time. Now you're going to use FIFA is a system so that we can easily solve all the calculation problems. So what does FIFA mean? So F for formula, insert the numbers, F for fine tuning it, and finally writing the answer. So here the first thing you need to do is write the formula down. So energy is power times time. I got it from the previous one, which we already solved. So again, this is something you need to know. Insert the numbers of energy. E for energy, and the unit you need to know is joules. What is the power? 7200 watt times time. What's the time? Which is we need to find out. We need to find out time. So we need to fine tune this because the equation is not straightforward. We need to rearrange them. So time equals 162,000,000. So we need to bring this 720 down. So 7,200, we bring it down, and now you divide it. You put this in the calculator. You get the final answer, which should be there. We go to 2500 seconds. So that will be a final answer. So the next one, again, you need to know the equation. V equals IR. So again, same system. FIFA FIFA. V equals IR. Voltage is 480 volt. Current is 15 ampere. And resistance. Again, fine tune them. 480 divided by 15. Your answer should be 32 ohms. There you go. Our next one. Here, charging system A has 13 amperes. Charging system B has 26 amperes. Both potential difference is 230 volt. So how long will charging system A take and charging system B take? So the time taken using system A is half the time of system B. That's not true because system A 13 amperes are being charged, and 13 plus 13 is 26. Whereas charging system B has a current of 26 amperes. So essentially this one, the first system, that is A, will take double the time to charge like B, because each second or each set of time you're getting charged 26, whereas the other one you're getting 13 amperes. So double the time will be needed for charging system A. So just have a think about it, which will take longer. If I am pouring 13 mils of water into a cup and 26 mils of water into a cup, which will be taking more time. So A will take more time because it's putting 13 mils, a little bit, little bit, little bit. Whereas in B, it's double faster, right? Okay, the next question. Energy from the sun is released by nuclear fusion. Complete the sentences. Nuclear fusion is the joining together of, it's already here, nucleus or nuclei. This is a plural of nucleus. During nuclear fission, the total mass of the particles decreases. That's why radiating energy. All right, let's get started with this question now. So here, the equation sheet should have an equation, and you need to go through it and you need to find the most suitable equation for this question. So this one, it will be delta E equals mc delta theta, and here theta means temperature change, right? It's also given in word equation, so you can say change in energy equals mass times specific heat capacity times, sorry, I don't have any more space anymore, let's just move this to the side, times temperature change, right? Now change in energy. So change in energy, it's not given. So what are we supposed to find out? We are supposed to find out energy, all right, or energy. Mass is given. So this is in kilograms, so we need to convert this into kilograms as well. So let's make it into 0.004 kilograms. Specific heat capacity is 52000 joules per kilograms times temperature change. Temperature change is 50,000 degrees Celsius. Right? Which, when we put them all together, we should get 1.04 times 10 to the power of 9 joules, or we can also write 1040,000,000 joules. Alright, this is also acceptable. On to the next question. The idea of obtaining power from nuclear fusion was investigated using models. The models were tested before starting to build the first commercial nuclear fusion power station. Why did we test them? Okay. So we could say to develop an understanding of the process. This is acceptable. We can also write assess safety risks. This is acceptable. These, if you write these two, I'll accept it. You can also say assess environmental risks. To make sure fusion is possible. Any of these answers are acceptable. Any two of these answers are acceptable. Alright, next one. Generating electricity using nuclear fusion will have fewer environmental effects than generating electricity using fossil fuels. So what is one environmental effect of generating electricity using fossil fuels? So you can say releases carbon dioxide. So fossil fuels are like petrol, diesel, burning coal. These are all fossil fuels. Okay. So coal, diesel, petrol, etc. So carbon dioxide release, it can also which causes global warming, by the way. If you write this, I will give you 2 marks easily, so that's fine. Okay, now on to our third question. Let's do question number 3. So this one is based off an experiment or a practical that you should have done in school. So student A investigated how current in resistor R at constant temperature varied with potential difference across the resistor. So he recorded both positive and negative values of the current. All right. So essentially you need to write a method for this question. So that's the question essentially, and this will be usually asked in every GCSE papers where you will be asked to write a method. So the key aspect of a method that is that all the steps are logically sequenced. So I would say write it in numbers. So they're logically sequenced. And it should have a valid outcome. Means at the end you should draw a graph or some sort of measurement. So these are the key points that you should have you should have in a method. Right. I'll go through this quickly. And the first thing you need to do is measure the current in resistance. Measure the current in R in the resistor using ammeter. That's a resistor and that's a voltmeter. And this is a variable resistor. And that is a battery. And this is a switch. You don't have to write this in an exam. This is for your understanding. So first measure the current using ammeter. Then you measure the potential difference across R using voltmeter. Now we are going to vary the resistance on the variable resistor. Vary the resistance on the variable resistor. Record the values of current and potential difference. So potential difference is essentially on the variable resistor, you're going to slide it up and down. If you don't understand what I mean, you need to go and watch a video of this experiment. So essentially on the variable resistor, I'm going to change the resistance by sliding it up and down. And once I do that, the voltmeter and the ammeter will show different values. The voltmeter shows the potential difference and the ammeter shows the current across this resistor, and this will change. So essentially you're going to note that, and after that you're going to draw a graph. Plot a graph of current versus potential difference, and you should have a graph of current and potential difference, and you should have the resistance. Okay, a couple of things you need to mention to get those full marks. Increase current slowly, or keep the current low to reduce temperature. Or keep the temperature the same. So that's one thing you need to keep in mind in order to get that full marks. All right. The student B, she repeated this experiment one more time. And so the resistor, the temperature increased. So the temperature increased. So how will this affect the result? So essentially, current and potential difference will not be directly proportional. Meaning, this graph will not have a straight line. Alright? So essentially it will be a curved. It will be something like this. Step. Alright. 3.3. What is the resolution of this moving coil ammeter? Okay. What is the resolution of this moving coil ammeter? So resolution means what does each of these readings mean? For example, that means 0 to 1, how many divisions are there? 1, 2, 3, 4, 5. So 1 divided by 5, you should get 2, 0.2. Okay. So the resolution is 0.2. That means each of these is 0.2. It should be 0.4, 0.5, and 0.6, sorry, 0.8, and 1. So essentially each these division is 0.2. 3.4. Student B replaced the moving coil ammeter with a digital ammeter. Figure 4 shows the reading out on the digital ammeter. Digital ammeter has a higher resolution than the moving coil ammeter. Give one other reason why it would have been better to use a digital ammeter throughout this investigation. So here it says higher resolution. What does higher resolution mean? That means here one of the problems with this moving coil ammeter is that you can't detect 0.1 or 0.001 because it's very difficult to measure something in between. It's either 0.0 or 0.2 clearly. Whereas in digital ammeter it's giving 1.34. It will give you 0.23. things like that. So it has a higher resolution. That's what it means. So why is it better? There are multiple answers for this. You can say less chance for misreading. Sorry, that looks terrible. Less chance of misreading. You can write no parallax error. You know what? A parallax error is when you look from the side and the value looks different. That's parallax error. So no parallax error. You know, sometimes when you're doing an experiment with your partner sees a different value and you see a different value. That's because you're looking straight ahead and your partner is looking from the side. That's why. Any one of them, all right? So any one of these two is the right answer. Okay. So one of the student is trying to investigate the density of these different fruits. All right. Density is how stuffed something is. So how closely stuffed something is. So that is the density. So it seems like in a kiwi, it is more dense inside a kiwi rather than an apple. Looking from the table. A student determine the volume of each of these fruits using a displacement can and a measuring cylinder. What other piece of equipment would the student need to determine the density of each fruit? So how can you determine the density? So quickly, density as a revision is mass divided by volume. So here he has determined the volume already. So how do you determine the mass? Simple weighing scale. That's right. You use a weighing scale or a balance. These are all acceptable answers. It's a 1 mark question, so any one of them. Write down the equation which links density, mass and volume. Again, as I mentioned before, density is mass divided by volume. Okay. Here, now you're using this formula for this question. What is density? 0.68 grams per centimeter cube. Mass is 85, it's given here, by volume. What's the volume? We need to measure it out. So essentially, it's a quick math trick. If you come into this situation, you just swap these. So that means V equals 85 divided by 0.68. You will get the answer, which is 125 centimeter cube. There you go. That's your answer. 4.4. The student only measure the volume of each fruit once. The volume measurements cannot be used to show that the method to measure volume gives precise readings. Give the reason why. So this guy, he measured only one time. So anytime when you're doing an experiment, you need to do repeat readings. Okay. So that means to show that the readings are close together. So repeat readings are necessary to show values are close together. Alright, that's it. Alright, so every year they ask a question related to the national grid. So you need to know how to solve this, but it's not really related to it. So you're supposed to calculate the mean energy transferred from national grid each second. So energy here in 1 year it is 1.25 times 10 to the power of 18. and in 1 year, number of seconds in 1 year, this is the time in seconds. Is 3.16. Calculate the mean energy transfer from national grid each second. So essentially you're just dividing the energy in 1 year divided by the number of seconds in a year. That's as simple as it is. One more time. This is the energy in a whole year, and this is the number of seconds in one whole year. So you're dividing it to find out the energy each second. So your answer should be 3.96 times 10 to the power of 10. Okay. Now have a read through this question. This is about the solar cells. We have the solar cell on the top of the roof, and we have a large battery and a cable. The charge flow through the cable between solar cells and the battery in 24 hours was 27,000 coulombs. What is the mean current? Right? So here, what is the time? You need to convert 24 hours into seconds first. So 24 hours times 60, this will convert into minutes, times 60, which will convert into seconds, which should give you 84, sorry, that's wrong, should give you 86400 seconds. Once you're done, now look at your equation sheet and should have the current, actually charge equals current times time. Okay, if it's not there on the equation sheet, you need to memorize this. Okay, so current, actually let's put the values. The charge is given, which is 27000 equals what? I is not given, you need to measure it, times t. T is 86400 seconds. So I equals, you're going to bring, if it is multiplication, you need to bring it down. So it will be 27000 divided by 86400, which is I, 25 amperes. So this will be the answer. Alright. At one time, the total power input to the solar cells was 7.8. The efficiency of the solar cell was 0.15. Calculate the useful power output. Now, the total, so efficiency equals useful power output divided by total power input. This is the equation. So the efficiency is 0.15 given here. What is the useful power output? It's not given. So that's what we need to find out. Divided by power input, which is 7.8 kilowatt. So again, you're going to multiply 0.15 0.15 times 7.8 gives you the useful power output, and your answer should be 1170 watt. Now the question is, how did I get 1170? Because I put 7.8, which is kilowatt. You need to convert this into watt, so you need to make it 7800. Right, so you need to convert kilowatt to watt. 0.15 times 7800, which will be the useful power output. So always make sure that you convert kilowatt to watt. All right. It is unlikely that all the electricity of the UK can be generated by solar systems. Why? Why do you think we can't depend fully on solar systems? So one of the biggest problems with solar cells is that you need large amounts of land to put the solar cells. All right, you need large surface area for solar cells. Also, you can say to low solar intensity, we can say a large area of land required for solar cells. So this will be the ideal answer, whereas this is also good. Too low solar intensity, number of daylight hours in UK is low. I mean, we hardly see the sun. That's also an acceptable answer. Sorry for my handwriting. Okay, now the next one is question number 6. All right, question number 6. Here there's a graph, there's a mass number given and the atomic number given. So how many neutrons are there in the nucleus of A? So number of electrons and number of protons and the atomic number, these are all the same. Electrons, protons, atomic number, these are all the same. All right. Now neutrons, number of neutrons is, yeah, that is correct, mass number minus atomic number. That is the number of neutrons. So in nucleus of atom A, that's we have 234, that's a mass number, minus atomic number, which is 86. So 234 minus 86, you should get 148. Which two atoms in figure 6 are the same element? So in figure number 6, so in this graph, which two atoms are the same element? So here A and C, they both have the same mass number. Are they the same? And D and E, they both have the same atomic number. So the answer is D and E. So D and E, same atomic number, they are the same element, right? D and E. If you are confused, look back at the definition of an isotope. Okay, so D and E, they have the same atomic number, they are the same element. Okay, here nucleus B decays by emitting an alpha particle. So it's a radiation and it's giving out alpha particles. Now remember, what's an alpha particle? If you go back, you will find that alpha particle is essentially helium atom, and helium has a mass number of 4 and an atomic number of 2. So essentially it's reducing by, the atomic number is reducing by 2. So here the atomic number is 88. So once it's giving, it will be reducing by 2. So it will be 86. And the mass number is reducing by 4. So 226 will be reducing minus 4. 226 minus 4. That is correct. That is 222. So it should be here. So if you draw this, you will get 2 marks. Okay. So again, this is the mass number, and this is the atomic number. And once it's really giving alpha particles, you need to subtract this and subtract this. Okay, what is meant by random nature of radioactive decay? So we can, this means that we cannot predict which nucleus will decay next. Okay, we cannot predict which nucleus will decay next. All right, question number 6.5. So polonium, that's polonium, is decaying first by alpha particles. So it's becoming into lead by emitting an alpha particle. Now remember, alpha particle is helium. Helium, which is 4 and 2. So 4 is the mass number and 2 is the number of electrons, number of protons, and the atomic number. Okay. Now that's the first one. And then lead is going to turn into bismuth by emitting an beta ray. Now recall what's a beta ray. So beta ray is essentially an electron, charged electron, which is -1 and 0. Okay. And then bismuth once again emits charged electron and 0. Okay. Now the question is, we started with polonium, and polonium gives you lead, then lead gives you bismuth, and bismuth again undergoes decays and becomes polonium again. So polonium starts with polonium and ends with polonium. The question is, how did it end up in polonium? That's the question. So take a minute and read the question one more time and try to figure out why. So some of you might have already figured out that one alpha decay, or the first alpha decay, remember this is how you write alpha decay decreased the proton number by 2, and the two beta decays, we have two beta decays increased the proton number by 2. By 2. Remember, minus 1, that means it's increasing it here, because here we're increasing it, and 2 plus 2 or just 2 over there, that means it's decreasing because it's giving out 2. I know it's a bit confusing, but just remember it's the opposite. All right, so plus 2 means it's decreasing by 2, and minus 1 means, or minus 1 plus minus 1, which is minus 2, minus here minus means it's increasing by proton number 2. All right, hence the atomic number, remember atomic number and the proton number is the same. Of the final nucleus is the same as the original nucleus. All right, so first alpha, the first alpha decay decreased the proton number by 2, and the two beta decays, increased the proton number by 2. All right, so the first one decreased by 2, and the second, these two increased by 2. So these two will cancel out. That means we are starting and ending the same. That's what it means. All right, so here question number 7. A student is investigating how the current in a series varies with resistance or variable resistor. So he's going to change the variable resistor, and he's going to check how the current is changing by looking at the values of the ammeter. Okay, so current and resistor, he put in the graph, and that's what he got. Now the battery had a power output of 230 megawatt, and when the resistance was 36 ohms. Now we need to calculate the potential difference. Now remember, potential difference is voltage, okay, and voltage is I times R. Okay, that's Ohm's law. Ohm's law. Sounds like Cole's law, but it's Ohm's law. Okay, so here we don't have voltage, we don't have current either. So how do we get the current? Now that's when you actually go back to the graph. Remember, look at the graph now. So here it says 36 ohms. So 36, that's 36. Okay, so what is the current here? 0.08. That's correct, 0.08. So the current is 0.08, resistance is 36, and you will get the answer of 2.88 volt, and that is a correct answer. All right, 7.2. So this student has concluded that current and resistance is inversely proportional to each other from the graph. Okay, so that means current is inversely proportional. What does that mean? That means that as current increases, the resistance is decreasing. But how do we know that for sure? Right? So the graph shows that as current increases, the resistance decreases. So you need to also add the product of current and resistance is a constant. Okay, that means at any point you take any of these values and multiply it, you should get the same number, which is 2.88. Okay, so which will be 2.88 at any point. So the product of current and resistance is a constant, is 2.88. All right, so if you show this using any of these values, any three values, I'll give you a full mark for that. Okay, so any three values, so take 0.10, and if I get 29, that will be, I will accept that, or 28. Okay, so that's right. So one more time, we have the battery, ammeter, and the variable resistor. You can see that the switch has been connected wrong here. So this switch has been connected here. It has to be, it actually had to be connected over here, but instead of that, we have the switch connected over on this side as parallel. So what does that mean? Okay, so they're asking you how closing the switch would affect the current in the variable resistor. How does it affect the current? So essentially, have a read through the answer. The current would almost be zero through the variable resistor because the switch creates a short circuit and effectively have a lower resistance. Actually, I'll say since it effectively have a lower resistance than the variable resistor. What does that mean? Seems like a lot of words. All right, let's break it down. Let's take a different highlighter here. So now it's connected in parallel. Current always like to flow through a circuit that has the least resistance. So that means as soon as you switch on, immediately the current will flow this way. Okay, before you switched on, the current was flowing this way. So current is flowing this way because that's the only circuit it has. Now suddenly you switch on, you put the switch on, and the current will start flowing this way. Because why? Because the switch has lower resistance here. There isn't much stopping it. Whereas variable resistor, there's lots of resistance. The current likes to prefer to go through this way rather than this way. So that means when the switch is on, there is almost no current going through this part. Okay, there is almost no current going through this part. So that's what this answer means. Good. So here, let's go through question number 8. So we have a car from A on a racing track, looping and going to D. Okay, so the first question asks you, this can be modeled as a closed system. Why can we consider it as a closed system? Because the values are constant. The total energy of the racing track and the car is constant. That's why we can call it. So whenever the keyword constant comes, we can call it a closed system. All right. The next one, here a car is released from rest position A and accelerates due to gravity to position B. The mass of the toy car is 0.04. The height between position A and B is 90 centimeters, which we can convert into 0.9 meters. And then gravitational field strength is 9.8. Now, what is the possible speed of the toy car? Now, you can use the kinetic energy formula, which is kinetic energy equals half mv square, and the v stands for velocity. Right? So kinetic energy is half mv square, and the v stands for velocity. This is what we need to find. But we don't have kinetic energy. We have the mass, which is this one. We don't know v, and we don't know this one, and we don't know this one. So we can't. So first of all, we need to find out what kinetic energy is, the energy is. And we can easily find the energy by going through this one. All the values are given. The potential energy, or EP, is mass times gravity times height. So the mass is 0.04 times gravity is 9.8 times height is 0.90 meters. When you do all that calculations, you should get the number 0.3528 joules. Now this potential energy is being converted into kinetic energy. Alright, so I'm going to move this here so that's convenient for us, and I'm going to move this closer here. Alright, so this arrow is pointing in the wrong direction. Alright, so now you have 0.3528 equals half. Mass is given 0.04 kilograms times v square. Now this is quite easy. All you have to do is rearrange, which will be 0.3528 times 2, because we are bringing from bottom, and then divided by 0.04 gives you v square. And from that, how do you get v from here? We cancel that out and put it a square root. The square root of the whole thing, and you'll get 4.2. And that's how you get the answer. Now the next one. So the same figure is put again so that you don't have to turn pages. 8.3. At position C, the car's gravitational potential is 0.2 joules greater than at position B. Okay, this one here, the potential energy is much greater. Why? So how much kinetic energy does the car need at position B to complete the loop of the track? So at position B, how much kinetic energy do they need? Do you need more than 2, less than 2, or exactly 2 joules? All right, let's go through it one more time. So essentially this car is going from B to C. It's going through a loop. At C, its potential energy is 0.2 joules greater. Okay, so how much kinetic energy? Remember, it's kinetic energy here because there is no gravity acting on it. All right, there's a gravity acting on it. That's why we have potential energy here, and here it's kinetic energy because it's moving, right? So in order to go through this whole loop, in order for this car to go through this whole loop, should it have more than 2? Yes, definitely. Otherwise, if it has less than 2, this car will fall down. Okay, because the gravitational potential energy, the energy that's pulling this car down, pulling this C down, is 0.2 joules. So you need to have it much more than 0.2 joules. So the reason is the car needs to move at the top of the loop. Okay. For the car to move through this loop, you need to have more than this potential energy. Okay. All right. Let's go through the ninth question. Here, a teacher demonstrates the relationship between pressure in a gas and the volume of the gas. Okay. So essentially, between pressure and volume. So this is the method that they used. So what is the range of force used? Okay, what is the range of the force used? So the initial volume of the gas in the syringe and the pressure reading before any weights are attached. Here, attach 2 newtons of weight to the syringe, 12 newtons. So what was the range used? If you write 2 to 12, I'll accept that. So 2 newtons to 12 newton, I will accept that. We can also write 0 newton to 12 newton. It's also acceptable. So this was the range used. Give one control variable in the investigation. What did he keep the same throughout the experiment? Alright, so what is the something that you kept same throughout the experiment? Alright, good. So temperature is kept throughout the same throughout. Temperature of gas, the mass of the gas, okay, both were kept the same. So any one of them will give you a right answer, give you a 1 mark. So when the volume of the gas was 45 centimeter cube, the pressure gauge showed a value of 60 kilopascals. Calculate the pressure in the gas when the volume of the gas in the syringe was 40 centimeter cube. Now here we are using the equation P1 V1 equals P2 V2. So if the volume of the gas is 45 and the pressure is 60, then pressure 2 when the volume is 40. Now from this you can rearrange. P2 is 60 times 45 divided by 40. And now the answer would be 67.5 kilopascals. So 9.4, when the volume of gas in the syringe is increased, the pressure on the inside walls of the syringe is decreased. Explain why. So if you don't understand the question, the first thing I will ask you to do is draw a diagram. Okay, so volume of the gas of the syringe, so the volume was increased. Alright, the volume of the syringe is increased. The pressure on the inside decreased. So if there were particles, okay, the pressure now decreased. Why? So if these particles have more space, isn't it? That is why. So there are less frequent collisions between the particles and the walls of the syringe. Walls of syringe. This causes a lower force on the walls of the syringe, and pressure is total force per area. So it's a force per area. So if I'm increasing the area or increasing the space, the pressure is decreasing. All right. Okay. Here you increase area, pressure decreases. So this will get you a full 3 marks. The mentioning of collision, mentioning of pressure is equal to force by area, and force acting on the walls. If you mention these 3 points, you will get 3 marks. Good. Now let's go on to the 10th question. Again, another question on the national grid. There are some power cables in the national grid. What is the advantage of transmitting electricity at a very high potential difference? Means high voltage. This question is going to be there in almost all of your exam papers. So you have to memorize this question. All right. There are 3 points you need to mention. High voltage means low current. Hence less heat energy is transferred to surroundings. This increases the efficiency of power transmission. All right, what does this mean? It means that when you increase the voltage, when you increase the voltage, high voltage, it has low current. Okay, when you increase the voltage, the current will decrease. That means low current means that you don't have much of the heat energy produced. So we are not losing energy through heat. So if when I'm producing energy in a generator, what I want is I want almost all of my electricity to be gone to the houses. I don't want to lose it as heat. The last thing I want is lose some of the electricity on the way. So that's what I'm trying to reduce. So what I will do is increase the voltage, which will decrease the current, which means it will decrease the amount of energy lost as heat. So we don't want any heat energy lost. Okay, so these are the 3 points you need to mention: high voltage, low current, less heat energy transfer. All right, this is for people who like to fly kites and people who said the GCSE as well. All right, This kid is flying a kite near a overhead power cable, but the kid could receive a fatal electric shock if the kite was very close to but not touching the power cable. Remember, the kite is not even touching it. It's coming very close to the power cable, but it says that it can be fatal. Why? You need to explain it why. All right. The kite conducts electricity to the person without the kite coming in contact because the electric field is very high, causing the air to be ionized. Okay, what does this mean? So imagine this is a cable. All right, this is a cable and a kite comes very close to it. All right, a kid flying a kite comes very close to it. All right, so if I zoom in, essentially the air here becomes ionized, because ionized means it becomes positive charges. So I'm gonna use positive or negative charges. This is being ionized. Okay, and the air becomes ionized because and it starts transferring electricity because this electric field is so high because of the high voltage. Okay, that means the area even around it has high electric field, and it will ionize even the air, so it will transfer the electricity through the air. Okay, that's why don't fly kites near electric cables. All right, here a scientist is investigating how the potential difference needed for air to conduct charge varies with distance between cable and earth. What does that really mean? So you know how cables are put on towers, on large towers, isn't it? And let's say this is earth, this is the flow, and that's the cables. So this scientist, he wants to make sure that how much distance will be needed for the air to conduct charge. All right, so this is the distance between earth and the cable. Okay, so he says that larger the distance, so let's say that one, this one, let's say this one is 0.15 and this one is 0.30. Okay, that's the cable and that's the ground or earth. All right, so he's saying that larger the cable, larger the distance, more energy, more potential is needed, more voltage is needed to conduct the electricity. Okay, now if you read this question, you'll see that the humidity of the air makes air a better conductor of electricity. All right, so if humidity is coming, you don't need a high voltage, don't need as much high of a voltage to conduct electricity. Okay, so where would the new line be? So they're asking you to draw a new line. So the new line will be just below. Why is it below? because you don't need a high potential energy. You don't need a high voltage to try to pass on this electricity. So it will be just below the previous line, because air is because the humidity means water. The amount of water in air is called humidity. So because water is a good conductor of electricity, you don't need as much of a high voltage. So the line will be just below. Okay, just go through this one more time and just have a think about this, because this question is a bit difficult and it really requires you to sit down and think about this question. Okay, so this is a 2 mark question. All right, now this is a cross section of a power cable. A 1 meter length of a single aluminum wire is better than a 1 meter length of steel wire. The individual wires behave as if they are resistors connected in parallel. So each of these wires act as if they are resistors connected in parallel. Okay. Explain why the current in steel wire is different to the current in a single aluminum wire. So they are asking you why the steel wire it is different from the aluminum wires. Now think about a parallel circuit. And what is the key qualities of the parallel circuit? If we have voltage connected and voltmeters connected in parallel, one of the key things is that the potential difference across each one will be the same. So potential difference across the cables are same because they are connected in parallel. Think about them as resistors connected in parallel. But the resistors the resistance of the steel is greater than aluminum, and hence less current flows through steel. Now the last